our next speaker is Dominik Nowak. Dominik is CTO at Usernet and CEO at Userian.
Yeah, and then the problem that Dominik is going to show us is about how to control remote robots. So it is easy when we are using our robot here in our table, and then we are programming the robot and seeing maybe the robot is moving around here, the same building. But what about if you have to control or you have to program robots which are located many miles away? So that's the subject of the presentation of Dominik here today. And Dominik, are you ready?
Yes, I'm ready. And it's great to be here. Great event so far.
Yeah, for the second time, right?
Right. The second time after, 2 years or
after
something.
2 years, yes, 2 years, great. We are very excited to have you here again. Then, Dominik, the audience is all yours.
Okay, thank you very much. As Ricardo mentioned, I'm here to present you how to control remote robots over the internet with low latency, and basically how to run different ROS2 nodes across the internet with low latency. We will make a very simple demo project where we just control the turtle sim by using 2 custom ROS2 nodes. But the end goal is to run turtle sim in the ROSDevDay, but run the, let's say, 2 control nodes just directly on your laptop. So your laptop and ROSDevDay are in totally different networks, many, even 1,000 miles away. And I will show you a way how to connect those, let's say, two devices over the internet with low latency. So let's take a look at the architecture of the solution. So we have got turtle sim and we have got 2 nodes, 2 very simple ROS nodes. The first one is just to control the color of the line drawn by turtle sim, and the second one is to control the move of the turtle. So a very straightforward, easy demo, but totally the same architecture could be applied to much more, complex solutions. So no matter whether your robot is just as easy as this one or very complex, or you control, a robotic fleet over the internet, you can apply the concept that I will mention here in any, let's say, project scale you have in mind. Basically, I created a GitHub repository. Yeah, and in this GitHub repository, you have got 3 examples that you can run directly on your laptop. At first, you need to have Docker installed. Here is instruction how to install Docker not only on Linux but also on Windows and Mac. At first, using Docker with ROS development during ROS development is a great thing. It will save a lot of your time. So this is why I Dockerized the whole, let's say, all examples to allow you run them by using only a single command in the Linux terminal. So basically, you have got one code base. So here is our custom package with 2 ROS nodes that I presented. They are written in Python. So you have got a color controller node and move controller nodes. And we run those nodes in different ways in these 3 examples that I will go through right now. So our first example is just run example number 1. So all 3 nodes are running in a single Docker container. So let's do that. So at first we need to clone the GitHub repository. Okay, let's go there. Let's open in Visual Studio Code. Okay, so we've got example number 1 here. So let's go to the example number 1 folder. Oh no, example number 1 will be run in different way. To run that, at first we need to make sure whether these two, let's say, scripts that are used by Dockerfile are executables. In my case, they are. And after that, we can simply use that command to build the Docker container. Okay, already done. After that, we need to give we need to provide a specific rule to allow our host system to share the screen to the Docker container. So let's do that. And after that, we can simply run our container. Okay, and this is the end result. So everything is working just in the single Docker container. So let's see how it looks like. So basically, this Docker container is very, let's say, this Docker file to build this Docker container and run this Docker container is very, let's say, short. We basically copy the ROS2 workspace to the Docker file system, and then run colcon build. That's all. And the end result is what you can see here. So nothing fancy. So let's improve our project a little bit. So the second example is to run the same example, but not in a single container, but in 2 separate Docker containers. Because basically it is a good, let's say, a smart move to run multiple Docker containers, focusing on a specific, functionality of your robot on a specific nodes. And it's not very smart to run everything in the single container. So let's divide our example in the 2 separate containers. And remember that we are still using the same code base than before, but we simply run that code base in different ways. Now in 2 containers, not 1. Okay, so let's go to example number 2 folder. Okay, and in example number 2 folder, we have got not only Docker file, but also Docker Compose file. And Docker Compose is much more handy way to run multiple containers than a simple Docker run command, because you can specify the whole configuration in the single file. That's something like a launch file, but for Docker. So as you can see, we run here our custom ROS2 nodes to control the turtle, and we execute ROS2 launch my turtle bring up only controller launch by. So this time we are not launching a turtle sim, because turtle sim is being launched by a separate Docker container. And as you can see, we do not have a separate Docker file for Turtle Sim, because Turtle Sim is available on the Docker Hub. So we only need to pull that and run it. So to running this container, this setup is even easier, because all you need to do is to use a single command. So sudo docker compose up, and let's build that also. Okay. So once more, nothing fancy, the same result, but this time we did it in much better way. So let's kill those two containers, and let's go back to our instruction. So everything is very easy right now, but the problem is, what if we would run those two Docker containers on two separate host systems, not in a single host system, but on two separate devices? And these devices are not in the same Wi-Fi network. One of them could be in Italy and another one in United States. And what is the easiest way to connect them together? So DDS in ROS2 will not work, because it works only within our local network. So we need to find a way to connect them, and the answer is using a VPN. So we can install VPN directly in those Docker containers. But again, it's not a very good move to install too much software within a Docker container. Single Docker container should be as lean as possible. So without modifying this Docker container, let's run a separate VPN container that will share a network interface with that container. On the other end, we will not run a Docker container, but we'll connect a Turtle SIM operating in this ROSDevDay together with our two ROS2 nodes operating on our laptop. So at first, we need to set up a free HusarNet account. So let's go to HusarNet website, and there you can see a login button. Let's click it, and let's create a new account. So some kind of login. And accept terms of service, and then our account is set up, and we should receive a confirmation email. So let's confirm our account. Yes, and after that, our free HusarNet accounts is there, so you can just use it. So let's create first HusarNet VPN network, in which we will have our two devices. So Docker container running on our laptop, and ROSDevDay that we are currently using. So let's name this network simply my network. Okay, and right now we are going to add new devices to that network. The easiest way to do that is to use a join code provided by HusarNet. It is a specific join code for a given network. So click Add button, and here is our join code. So I will show you how to use that join code to connect our devices together. So let's copy that to the clipboard. Let's go to our ROSDevDay, and at first we need to run. We need to run HusarNet daemon here because ROSDevDays are not provided with systemd by default. So if you use systems that do not have systemd, you need to run a HusarNet daemon in a separate window. But on typical, laptop, Linux laptop distribution, this step is not needed. So let's connect this ROSDevDay to our HusarNet network. To do so, we use a command sudo husarnet join and paste our join code here. And let's name our device simply as ROSDevDay1. This ROSDevDay1 is a host name that could be used by other HusarNet networks, HusarNet devices, to access this device over the internet. Okay, so we just added ROSDevDay to the HusarNet network. Let's take a look at our network right now. Let's refresh the screen. Okay, and as you can see, right now our VPN network contains a ROSDevDay device with IPv6 address as you can see here. And to access the ROSDevDay from a level of any other device, you can use hostname or this IPv6 address. Of course, this is virtual IPv6 address provided by HusarNet, but you can, use that just as it was, IPv6 address provided by your network interface, because basically HusarNet creates a virtual network interface on top of your operating system. Okay. So now let's add our Docker containers to the same HusarNet network. To do so, let's go to example number 3 folder. Okay, and then in this example number 3 folder, we have got, of course, our Docker file. And we install here a Cyclone DDS instead of default DDS in ROS2 Foxy. However, with fast DDS, it would work completely the same way. On our website, there is instruction how to configure both types of DDS. And a very important file is Cyclone DDS XML file. Here you can provide, let's say, network configuration, allowing your ROS nodes to discover each other. And the most important line is here. So we need to specify our peers that will be accessible from this Docker container over the internet by using HusarNet. And you can provide here just a host name right here. As you can see, this is ROSDevDay1, and ROSDevDay1 is the host name we already used to connect our ROSDevDay to the HusarNet network. So that's fine. So we do not need to change anything here. So let's just run that container. Oh, sorry, I forgot about a very important step. Okay, so we need to also specify this join code and use that within a Docker container that we are running, to allow this Docker container to connect to our specific network. So each join code is unique. So this is the join code that will work only with my specific network, but it will not work with yours network. So, okay, let's rerun this example. Okay, let's wait a few minutes, a few seconds. Okay, here we go. As you can see from this log, so we have got here logs from 2 separate containers. So there is a HusarNet container and there is starter controller container. And from HusarNet container, we have received IPv6 address of that container. and the same IPv6 address is available here. Okay, you can see. Okay, so now in our network we have got two devices. So right now we need to configure a DDS in ROSDevDay to allow those two, let's say, allow ROS2 nodes operating on those two machines to discover each other. So let's go back to our ROSDevDay, and this time we will configure DDS here. So let's open a code editor. Okay, and here you can see the same Cyclone DDS configuration file, but this time we need to provide here address of IPv6 address of the container working on our laptop. So as you can see, we pasted here IPv6 address of Tartar controller 1. So this is the host name of the container running on our laptop. Okay, let's save the file. Okay, and right now, let's simply run it. Okay, but before we run it, we need to at first install also Cyclone DDS here. As mentioned, for ROS2 Foxy, Cyclone DDS is not default. We need to install that. So, okay, here in our GitHub, I have got instruction how to install that DDS. So at first we need to update and then install Cyclone DDS. Yes. Okay, we need to wait a few seconds, maybe more. Oh, have it stuck or something? Okay, let's give it a couple seconds more. No. Okay, maybe we need to kill it and try to install that one once more. Okay. So. Huh. Okay. Oh, it looks like Cyclone DDS is already installed, so everything is fine. So right now we just need to at first source we need to source ROS2 Foxy. We need to export a middleware implementation Cyclone DDS to be used by our environment. Whoa, something strange happened here. So, okay, and let's export also a URL to our Cyclone DDS configuration file. Okay, and let's run the simulation. Okay, to see the simulation inside the ROSDevDay, we need to open graphical tools. Okay, and as you can see, We have got the same result as before, but this time our turtle controller nodes are working inside on our laptop. Okay, so as you can see, our turtle controller nodes are working on our laptop and are controlling that simulation operating in totally different network. To verify whether our nodes operating on our laptops are controlling the starter, we can simply kill those two Docker container working on our laptop. And the turtle should stop. Okay, as you can see, turtle has stopped because it no more receives commands from our laptop. But right now we can rerun the container. So the turtle will continue moving. Okay, as you can see, everything works fine. Basically, it's, as you can see, it's very easy to set up this VPN connection between remote ROS2 nodes. And as mentioned before, this system can contain not only, let's say, 2 devices like here, but you could have even dozens of devices, of dozens of containers operating in the single VPN network and spread across the internet. And the very important fact is that those containers are connected peer-to-peer, because HusarNet is a peer-to-peer VPN network. So it allows you to connect your devices just directly over the internet, even if they are behind NAT or firewall. So, for example, my laptop do not have public IP address. It is connected to my Wi-Fi router, but from a level of other HusarNet devices, my laptop could be accessed like it had public IP address, and the traffic between those devices is peer-to-peer, is secured, is encrypted, so you do not need to worry about security or something. And I have got a great announcement here for you, because starting today, HusarNet goes open source. So it's a pleasure for me to announce that fact during this conference, this great ROS2 conference, because we designed HusarNet with ROS and ROS2 in mind, to allow you to give you a tool allowing you to connect your ROS2 devices over the internet in very fast and in very easy way. So yeah, right now you can just clone this GitHub repository, modify HusarNet, build your own version, or just see how it looks like, how it works. As you can see, it's written in C++. It's very lightweight, it's very fast, it's very secure. So yeah, so basically that's all. It was a pleasure to be here and to present you HusarNet and how to use HusarNet to connect various ROS2 nodes and ROS1 nodes over the internet. And we can go to Q&A session right now.
Wow. Dominik, what an announcement there. Hello, Dominik.
Hello,
can you hear
me? Yes, I can hear you, Ricardo.
Okay. Can you switch back to your camera so we can see you?
Yes.
Great. There you are.
Okay.
Great. And then what an announcement about putting Usernet open source. Now, which other details? Yeah, congratulations. So it's a very good movement for the community, for ROS specifically. And can you give us any other detail about this?
So yes. Basically, we know how important is open source software for ROS2 community, and we and to allow you use Husarnet in much easier way. We simply decided to go open source to show you that we do not have anything to hide. And that we, totally, you can totally trust Husarnet and its security, its low latency, it's lightweight, and everything is, available just on our GitHub page.
Yeah, that you mentioned, it's a very cool point. It's about the trustability, because whenever you ask somebody else to install your server in their robots, they start to think, okay, what are you installing here in my computer, in my robot, and so on. So it's a very good idea.
Yeah. So especially that this is the product, that you need to trust, right?
Exactly.
It's something that allows you to send your packets back and forth, and you need to know what is, what is under that. So as mentioned before, Husarnet is peer-to-peer technology. So your packets don't go through our servers. So there goes peer-to-peer over the internet. So even without going open source, we do not have access to the packet as a platform provider. But it is, let's say, next step in transparency, in simply giving something forward to the open source community and to great ROS and ROS2 community.
Awesome. Let me ask you one question before I go to the people there. But you mentioned that it's a peer-to-peer, so it means that is your computer, which is connected to, the user computer connected to the robot of the user, which is located somewhere else, and it's not going through Usernet servers. The communication is direct between those two, right?
Right. This is right. So of course we have Husarnet servers, but those servers are used only to help your devices to find each other over the internet and to establish a peer-to-peer connection. And the great fact about Husarnet is also that we created that with ROS and ROS2 in mind. So in many robotic use cases, robot, for example, can be switching from one Wi-Fi network to another one, and on typical, let's say, VPNs available on the market, this switching time is a nightmare because it takes a lot of time. And in Husarnet, we optimize the time. So, for example, if your robot is switching from Wi-Fi router to another one, or from Wi-Fi router to LTE, and then this reconfiguration time, so re-establishing a peer-to-peer connection took somewhere between 1 to 3 seconds only.
Oh, wow.
So it's really, really fast. So you have not only, let's say, low latency in packet communication, but also low latency in, let's say, changing a network topology.
Okay, very good point. Worth to be clarified. Let me start with the questions, but before, I want to say to the audience that you can put your questions on the questions tab that is located on the conference panel. And then you can put your questions there. Also, both the questions that are already there, and I will be asking those questions to Dominik here on the microphone. And in the meantime, that people are putting more questions. There are several already there. I'm going to go on those questions in a minute, but let me ask you myself one. So you are mentioning about low latency in your network, but I suppose that this is going to be one of the questions there on the chat. And what about when we are changing to a 5G network? How is this going to affect Usernet? Or is it going to affect in any sense?
So HusarNet is independent from any, let's say, network connectivity layer. So you can use HusarNet over Ethernet, over Wi-Fi, over LTE, over 5G. And in all cases, the traffic between your devices connected over the internet goes peer-to-peer, goes directly using the lowest latency path. So it doesn't matter how your devices are connected over the internet, basically.
Okay, then if we use the 5G, then we should expect even a lower latency.
Yeah.
So it's going to even improve, right?
Yes. So basically, HusarNet operates in totally different networking layer than 5G, Wi-Fi, or LTE. So it's basically three and four layer. Let's say product 3 and 4 layer technology of ESO OSC model networking stack. So yes, basically it works on top of existing network interfaces, and HusarNet create basically a virtual network interface on top of your operating system. Mm-hmm. So it works in background and from a level of your existing software working on your laptop. It's simply just another network interface that you can list and access from any other device.
Great. Clear now. So let me ask you the first question, the most voted one by Haomin Zhang. And he says, how big is the bandwidth of Usernet VPN service? Is the VPN capable of transfer images and LiDAR data or point clouds?
Yes. So we tested HusarNet with 1 gigabyte, let's say, bandwidth, and everything works fine. So if let's go to the GitHub repository, and here we mentioned about top, let's say, features of HusarNet, and one of them is being lightweight. So HusarNet is written totally in C++. And is optimized to run very fast and very smoothly with let's say, large amount of data. Mm-hmm. HusarNet is so lightweight and so optimized that we even managed to run that on a Wi-Fi microcontroller ESP32. So something that even does not have operating system, and it's a simple microcontroller. So if it runs, on top of so simple and so low powerful devices, then for sure on typical computers, on Intel NUC, for example, in your robot, it will work very, very smoothly without wasting processing power of your computer.
Amazing, very cool. Then let me go to another question by Pablo Puente that he says, is any special configuration needed to traverse company firewalls, proxies, or NAT?
So HusarNet, let's say, can go through NATs by default. So my laptop was behind NAT. And as you can see, in most cases, you even don't need to worry about that. So of course, there are, let's say, situations where peer-to-peer connection is not possible. And one of the reasons if you are not behind one NAT, but we are two NATs, right? But two NATs, it's basically that if you are behind two NATs, it basically means that your network configuration is broken, okay. And you need to fix that. But basically, in most cases, if you are behind a single NAT and the device on the other side of globe is also behind a single NAT, then behind firewall. Then HusarNet simply works, and you do not need to worry about that.
Okay, great, qualified. And then one question very, very much voted also from Lucas Softzak, and he says, what about the delays in connection between the robot and the PC in using Usernet VPN? Is it okay for real-time teleoperation?
Okay, so I have closed my ROSDevDay, but if I haven't closed it, I could ping the Docker container running on my laptop. So then you can see the latency. But let's say when it comes to latency added by Husarnet itself, so you can test it just by pinging, for example, 2 VPS servers on different let's say signs of globe. And while testing Husarnet in such a configuration and comparing ping times between using just public IP address or IP address provided by Husarnet, then latency introduced by Husarnet is below 1 millisecond. But of course, if you connect different computers over the internet, I know, let's say typical latency and typical pings between my office and let's say my home. That is, let's say 20 kilometers from my office, is about 20 to 30 milliseconds. So latency is let's say ping time divided by 2. So that means that latency between my home and my office over the Husarnet is just 15 milliseconds. So you can even run telepresence robots using that network, and everything goes peer-to-peer, and latency is as low as possible.
Yes, yeah, exactly. So basically, that depends also on where is located the robot from you. So you will have larger latencies, and then in this case, 5G, when it comes, then it can help to even reduce this. So we are going to go to a better position. In any case, having less latency. Let me ask you another question from Pablo Puente, and he says, is IPv6 mandatory, or does Usenet work with IPv4?
Okay, this is a very, very good question. So Husarnet basically works on top of IPv4 or IPv6 network. It doesn't matter. However, Husarnet provides IPv6 overlay layer, So it's a virtual network interface. So if you would use Wireshark to monitor the packets, so you will see only IPv4 packets, let's say, going back and forth over your local network. But on the level of Husarnet, it's IPv6.
Okay. Then another question, more questions that we have here. Let me see. Okay, so here we have okay, so I don't know very much about this question, but I'm going to ask you directly. Maybe you can make it more sense. From Sven Rombach. And he says, can Usenet be configured to be included in a Yocto project for a minimalistic embedded Linux system, such as one deployed in a commercial system? Yocto, Yocto is a system for...
I know Yocto Linux, and yes, in the past we used Husarnet also on Yocto Linux. So yeah, it looks smoothly on this distribution. Basically, we have builds for all popular architecture. Like you can run Husarnet on Raspberry Pi, even on old Raspberry Pis with 32-bit architecture, with ARM64. With all Intel architectures, and even with vRISC architecture. So all, let's say, popular computer architectures are covered by Husarnet client. So yeah, you can basically run that on any hardware platform. However, currently we have launched only Linux version. So you can run that on Ubuntu, on Fedora Linux, or let's say all popular Linux distribution. But Windows, Android, and macOS versions will come soon in 1 to 2 months from now.
Okay. Yes. Actually, on the video that we have broadcasted at the beginning of the conference about Usernet and asking the question and so on, we were indicating that you are in the process of supporting Windows and also Android and Mac and so. And then here a question is interesting by Vinicius that says, does it work only outside a Docker? Because you have done the demonstration here by using Dockers, but can you answer this question if it is possible to use it outside?
Yeah, absolutely. You can use that working directly on your host system. But if you want to use that only within a Docker container, then you don't even need to install that on top of your host system. So from a level of HusarNet, if you install HusarNet on top of your host operating system and inside of the Docker, then you have two separate HusarNet devices sitting on top of your single laptop.
Mm-hmm. Okay.
Okay, so basically, your laptop, your host operating system could be, let's say, a separate device than any number of separate Docker containers that you can run in the background.
Great. Yeah, actually, we have used it here at the construct without the Dockers and with Dockers also, but so it's safe and it works. Then let me tell you another point, which is about the pack that you are giving away for all the attendants to the conference of Usernet access. Can you clarify to the audience what is this pack about?
Mm-hmm. Yeah. So during my presentation, I mentioned that we will set up a free HusarNet account. And this free HusarNet account allows you to connect up to 5 devices for free over the internet. So in most, let's say, education or hobby use cases, it's enough. However, for all attendants of this conference, we provide a commercial account for 6 months, allowing you to connect up to 100 of devices.
Great. So we are going to send this package to all the attendants to the conference after the conference in an recap email that we are going to send next week with all this. So you will be able to use this Usernet package and connect many devices up to 100 for 6 months, as Dominik has mentioned. Then one final thing that I would like to tell to the audience is about the questionnaire. So you have announced here at the conference that you are releasing Usernet as open source to the audience. That's a brave movement, and I wish you the best of luck on this, and I hope that the community is going to support. But also, you need to know about the opinion of the audience, of the ROS developers out there, so they can give you some feedback about what they think about Usernet and how to improve. So we are going to share now on the chat a link to the questionnaire with just a few questions, I think no more than 5. And then if you are happy, all the ROS developers out there, if you can help Usernet on filling that questionnaire and providing your opinion, that will be very useful for them. And will benefit at the end because they will change the code and put it open source afterwards. Great. So far so good, Dominik? Are you still there?
Yes, I'm still there. So
okay.
It's great to be there. It's a very, very great event, Ricardo. So congratulations.
Thank you.
I'm happy to be here. And good luck, guys.
Thank you. And it was your honor that you mentioned these big news. So remember, ROS developers out there, that you heard this news first at the ROS Developers Day. And so it was our honor to host this new. And thank you very much, Dominik. See you around the universe.